In this video, we will discuss about basic electrical and electronics engineering, Unit 2, AC circuits, question bank solutions, Part B. Derive the expression for average value, RMS value of alternating sinusoidal current waveform. This waveform is the alternating sinusoidal current waveform. Time period is T equals to 2 pi to complete the full cycle. Since the given waveform is an alternating waveform, we are able to find out the average value only for half cycle. Since if you find out for full cycle, the average value will be 0. So we will find out average value for half cycle. Time period equals to 2 pi. Since the given waveform is alternating current, hence the average value over a full cycle is 0. So we need to find out the average value for half cycle only. So we will consider the time period T equals to pi. F average equals to 1 by T integral 0 to T f of t dt. Since the given function is a sine waveform, I am sin omega t. Now we will able to find out the I average equals to 1 by pi integral 0 to pi I am sin omega t d omega t. If we take I am common, I am by pi, integration of sin omega t is minus cos omega t with the limits of 0 to pi. Now by substituting the limits, upper limit as well as lower limit, now we are able to find out the expression for I average equals to minus I am by pi. Upper limit is pi, lower limit is 0, cos pi minus cos 0. Since the value of cos pi is minus 1 and the value of cos 0 is also cos 0 is 1, then the value of I average equals to minus I am by pi into minus 1 minus 1. Now this will be I average equals to 2 I am by pi. This is the average value of an sinusoidal current waveform. Now to find out the RMS value means root mean square value. It can be found for full cycle. Now the formula for RMS value is FRMS equals to under root of 1 by t integral 0 to t f of t whole square dt. IRMS equals to under root of 1 by 2 pi under root of 1 by 2 pi integral 0 to 2 pi I am square sin square omega t d omega t. Since if you take common I am square by 2 pi into integral 0 to 2 pi sin square omega t d omega t. Now we can write sin square omega t as 1 minus cos 2 omega t by 2. Now if you separating the first term and second term, integral 0 to 2 pi 1 into d omega t minus integral 0 to 2 pi cos 2 omega t dt. Now integration of 1 is t and the integration of cos 2 omega t is sin 2 omega t by 2. RMS equals to I am square by 4 pi, upper limit is 2 pi minus 0 minus sin 4 pi by 2 minus sin 0 by 2. Here IRMS equals to under root of I am square by 4 pi into 2 pi minus 0. The pi will be cancelled. IRMS equals to I am by root 2. It is the RMS value of a sinusoidal alternating current waveform. A circuit consists of a resistance 50 ohms, capacitance of 200 microfarads and inductor of 0.08 henries all in series. If the supply of 200 volts 50 Hz is applied to the ends of the circuit, calculate the current, voltage across each element, phase angle and power factor. Given R equals to 50 ohms, L equals to 0.08 henries and C equals to 200 microfarads. Now here he need to ask the value of current. The formulas here used are, the given data is R is 50 ohms, C is 200 microfarads, micro is nothing but 10 power minus 6. Inductance L equals 0.08 henries and voltage is 200 volts and frequency is 50 Hz. Formulas used are angular frequency omega equals to 2 pi f, capacitive reactance Xc equals to 1 by omega c, inductive reactance XL equals to omega L. Now, and the value of current I equals to V by Z, where Z equals to R plus Z equals to R plus J XL minus J XC. Here R is a real term, R is a real term resistance, and XL is the inductive reactance and XC is the capacitive reactance. And the voltage across each element we can obtain by using the formulas. Voltage across resistor is equals to I into R, voltage appear across inductor is I into XL, and the voltage appear across capacitor is I into XC. And phase angle is phi and the power factor is cos phi. Now by substituting the values we can obtain omega equals to 2 pi f, where f is the frequency which is equals to 50. Therefore we can obtain 2 pi into 50, which is 314.15 radians per second. And XC is equals to 1 by omega c. By substituting the values we can, the value of capacitance is 200 microfarads, therefore we can obtain 15.915 ohms, and the value of XL equals to omega L, which is 314.15 into 0.08, therefore which is equals to 25.132 ohms. The units for inductive reactance is ohms, and as well as capacitive reactance also ohms. The formula for Z equals to R plus JXL minus XC. Now we can obtain R is 50 ohms and the values of 50 plus J XL value is 25.132 minus J XC. XC value is 15.915. 50 plus, now you can able to find out 50 plus J 25.132 minus 15.915, which is equals to 50 plus J 9.217, which we can converting into polar form, which is 50.84 at an angle of 10.44. Current I equals to V by Z. V voltage given is 200 volts. V divided by 50.84 at an angle of 10.44. We can obtain the value of I is equals to 3.933 at an angle of minus 10.44. Here the voltage across each element V are equals to I into R, where I is 3.933 into the value of R is 50, which gives 196.65 volts, and the value of voltage across the inductor, which is I into XL. I is 3.933 into XL value is 25.132, which gives 98.844 volts, and the value of voltage appear across the capacitor is I into XC. I is 3.933 into XC value is 15.915, which will gives the voltage appear across the capacitor is 62.59 volts. The phase angle phi is given by, from the current we can obtain the value of phase angle phi, which is 10.44, and the power factor is cos 10.44, which is equals to 0.983 lagging. Since the circuit is in inductive nature, since the value of XL is dominating, lags, current is lags, power factor is lagging. Here explain in detail about series R circuit with sinusoidal excitation. Consider an RC circuit consisting of a resistor R and a capacitor C excited by a sinusoidal alternating voltage V equals to Vm sin omega t. For the circuit shown in figure, by applying KVL, we can write V equals to VR plus Vc, where V is the supply voltage and VR is the voltage drop across a resistor, which is equals to I into R, and Vc is the voltage drop across a capacitor I into Xc, and the I is nothing but instantaneous value of current. Now you can draw the phasor diagram. By taking current as a reference, voltage across resistor is VR, will be in phase with current, and the voltage across capacitor is Vc, lags the current by an angle of 90 degrees. From the phasor diagram, we have V equals to VR plus Vc, which is a phasor sum. Therefore, V square equals to VR square plus Vc square. Now we can write V square equals to I into R square plus I into X square. Now from that you can find out the value of Z, impedance Z equals to R minus JXC. The phase angle phi equals to tan inverse of Xc by R. Now to find out the power relationship, power P equals to Vi, where V is Vm sin omega t and I is Im sin omega t plus pi. Since it is a capacitor, we will have the current leads by an angle of phi. Then the product of Vi is P equals to Vm into Im into sin omega t plus pi. Now we can divide with 2 and multiply with 2. We can write this expression as Vm into Im by 2 into 2 sin omega t plus pi. Therefore P equals to Vm into Im by 2 cos pi minus Vm into Im by 2 cos 2 omega t plus pi. Since the cos 2 omega t plus pi term is, since the average value over a half cycle is 0, the value of cos 2 omega t value is 0 over a half cycle. Therefore power P is equals to Vm into Im by 2 cos phi. We can write this one as Vm by root 2 into Im by root 2 into cos phi, where Vm by root 2 is called RMS value, which is represented with capital V, and Im by root 2 is represented with capital I. Therefore P equals to Vi cos phi. Resistance of 20 ohms and a capacitance of 100 microfarads are connected in series across a 220 volts 50 Hz supply. Now in the given problem, now you can draw the circuit with the resistance R equals to 20 ohms and the value of capacitance C equals to 100 microfarads. Now R is 20 ohms, 100 microfarads, we can write it as 100 into 10 power minus 6 farads, and voltage V is given, which is 220 volts RMS value, and F is given, F equals to 50 Hz. The formulas used are, first of all, omega, which is angular frequency, omega equals to 2 pi f. Capacitive reactance X equals to 1 by omega c, and impedance Z equals to R minus JXC, and the value of current I equals to V by Z, and the phase angle is phi. We will obtain phase angle from the current formula I equals to V by Z, and the voltage across each element is given by voltage across resistor equals to I into R, and the voltage across capacitor is I into Xc. Active power is given by Va cos phi, and the reactive power is given by Vi sin phi. Now by substituting the values, we can obtain omega equals to 2 pi f, which is 2 pi into 50, which is 314.15, and the value of Xc is 1 by omega c, the value where the value of capacitance C equals to 100 microfarads. By substituting the values, we can obtain the value of capacitance is 31.83 ohms. By substituting here R minus JXC, R value is 20 minus J 31.83. Now we can convert it into polar form. If you convert it into polar form using calculator, 37.59 at an angle of minus 57.85. This is the value of 20 minus j 31.83, which is in terms of polar form 37.59 at an angle of minus 57.85. Now by using the formula I equals to V by Z, where the value of V is 220 by the value of Z is 37.59 at an angle of minus 57.85, we can obtain the value of current I is 5.852 at an angle of 57.85. Now we can find the value of voltage across each element. The voltage across resistor R is given by VR, voltage across resistor VR equals to IR, which I is given by 5.852 multiplied by the value of resistance is 20, which will gives 117.046 volts. Similarly, the voltage across capacitor equals to VC equals to I into XC, where the value of I is 5.852 multiplied by XC value is 31.83, which will use the value of 186.27 volts. And the value of active power is VA cos phi. We know the value of voltage V is 220 multiplied with I value is 5.852 multiplied with cos of angle is 57.85, which is equals to 685.09 watts. Similarly, the reactive power is VI sin phi. The value V voltage is 220 into 5.852 into sine of 57.85, which is equals to 1090.02. The units for reactive power is volt ampere reactive, or we can write it as 1.09 kVAR, kilovolt ampere reactive. Now the active power can also be written in terms of 0.685 kilowatt. Explain in detail about series R circuit with sinusoidal excitation. Consider an RL series circuit consisting of resistor R and inductor L excited by a sinusoidal alternating voltage V equals to Vm sin omega t. For the circuit shown in figure below, by applying KVL, we can write V equals to VR plus VL, where V is the supply voltage, VR is the voltage drop across resistor, which is equals to IR, and the VL is the voltage drop across the inductor, which is I into XL, and I is the instantaneous value of current. By taking current as reference, voltage drop across resistor VR is always in phase with current, and the voltage drop across inductor VL is leads the current by an angle of 90 degrees. From the phasor diagram, we can write V equals to VR plus VL, which is a phasor sum, and V square equals to VR square plus VL square. Therefore, we can write it as IR square plus IXL square, and the value of impedance Z equals to R plus JXL, and the value of phi equals to tan inverse of XL by R. Power P equals to product of voltage and current, which is equals to Vm sin omega t into Im sin omega t minus pi. Now here also we can multiply with 2 and divide with 2. Then we can write this expression as Vm into Im by 2 cos pi minus Vm into Im by 2 cos 2 omega t minus pi. Since the value of cos 2 omega t value over a half cycle is 0, we can neglect this one and we can write power P equals to Vm into Im by 2 cos pi. We can write it as in terms of RMS values, where capital V represents Vm by root 2 and capital I represents the Im by root 2. Therefore, P equals to Vi cos phi. Explain in detail about RLC circuit with sinusoidal excitation. Consider an RLC series circuit consisting of resistor R, inductor L, and capacitor C, excited by sinusoidal alternating voltage V equals to Vm sin omega t. For the circuit shown in figure, by applying KVL, we can write V equals to VR plus VL plus VC, where V is the supply voltage and VR is the voltage drop across resistor, which is equals to IR, and VL is the voltage drop across inductor, which is equals to I into XL, and VC is the voltage drop across capacitor, equals to I into XC, and the value of I equals to instantaneous value of current. Taking current as a reference, voltage across resistor VR are always in phase with current, and the voltage drop across inductor VL is leads by 90 degrees, and the voltage drop across capacitor VC lags by 90 degrees. From the phasor diagram, now here the phasor diagram will be depends upon the value of VL and VC, which is nothing but XL and XC. If the value of XL greater than XC, the figure 1 represents XL greater than XC. Now in this case, automatically the value of VL is greater than VC. The first triangle gives the impedance triangle gives the if XL is greater than XC. In the second case, it is XL is less than XC. Now in that case, the capacitor VC is dominating more than, which is greater than VL. Therefore, this is the phasor diagram in case of XL less than XC. And the third case is XL equals to XC. If XL equals to XC, the value of VL is equals to VC. Then corresponding, this is the phasor diagram. The value of instantaneous current I is given by I equals to Im sin omega t plus or minus pi. Then the value of pi equals to tan inverse of XL minus XC by R. And the value of power P is obtained as P equals to Vi, which is equals to Vm sin omega t into Im sin omega t plus or minus pi. Then here also by multiply with 2 and divide with 2, you can able to find out the value of Vm into Im by 2 sin omega t into sin omega t plus or minus. Here also cos 2 omega t value is 0 over a half cycle. Then the value of power P equals to Vm into Im by 2 cos pi, which is equals to Vrms into Irms cos pi, or P equals to Vi cos pi. Compute the form factor and peak factor for sawtooth wave. From the given data, we have to calculate the function from the limits of 0 to t. Now the value of I of t is varies from 0 to t comma Im. From the slope equation, I of t equals to Im by t capital T into t minus 0. Therefore, I of t equals to Im into small t by capital T equals to 1 by t into 0 to t f of t dt. The value of I average is equals to 1 by t into 0 to t, where f of function is Im into small t by capital T into dt. Therefore, I average is equals to 1 by t square into 0 to t Im into small t dt. Now if you take common of Im by capital T square into 0 to t 0 to capital T small t into dt. I average is equals to Im by capital T square into integral t is t square by 2 with limits of 0 to capital T. Now by substituting the limits t square by 2 minus 0, then the value of I average is equals to Im by 2. It is the average value of a sawtooth waveform. RMS value means root mean square value. F RMS equals to under root of 1 by t integral 0 to t f of t whole square into dt. Now we know the function f of t equals to Im into small t by capital T, and the limits are with 0 to capital T. Now if by substituting the values, IRMS equals to under root of 1 by t into 0 to t Im into small t by capital T whole square into dt. Now it is 1 by t into 0 to under root of 1 by t into 0 to t Im square t square by capital T square into dt. IRMS equals to under root of Im square by t cube into integral 0 to capital T square dt. IRMS equals to under root of Im square by t cube into t cube by 3 with limits of 0 to capital T. Now by substituting the limits, we can find out the value of IRMS equals to Im by root 3. Form factor equals to RMS value by average value. The value of RMS value is Im by root 3 and the value of average value is Im by 2. Therefore Im will be cancelled, which is equals to 2 by 1.732, which is equals to 1.154. and the value of peak factor is maximum value by RMS value. Maximum value is Im and the value of RMS value is Im by root 3. Im will be cancelled, which is 1.732. It is the values of form factor and peak factor for a sawtooth waveform. To compute the form factor and peak factor for a square waveform, the time period is time taken to complete full cycle is t. Since the given waveform is an alternating waveform, hence the average value over a full cycle is 0. So we need to find out for a half cycle. Therefore the time period is equals to t by 2. Function v of t equals to v naught from with the limits of from 0 to t. Time varies from 0 to capital T by 2, where v of t equals to minus v naught from capital T by 2 to t. Since the average value will find it for only for half cycle, the average value f average equals to 1 by t integral 0 to t f of t dt. Now here we are finding only for half cycle only. Since if we find it for full cycle, the average value will be 0. So we are finding the value of average value only for half cycle, which is 1 by capital T by 2 integral 0 to t by 2 v naught into dt. The value of v average equals to, now by solving here by substituting the limits, and we are able to find out the value of v average is equals to v naught. RMS value f RMS equals to under root of 1 by t into 0 to t f of t whole square into dt. Now by substituting the values, we are able to find out the value of RMS value as well as average value. The RMS value is average value you are finding is of average value you are finding v average equals to v naught, and the value of RMS value you are finding v RMS is also equals to v naught. The values of form factor and peak factor is form factor is RMS value by average value, which is equals to 1, and the value of peak factor is also maximum value by RMS value, which is also equals to 1. Find the form factor and peak factor for half wave rectifier output. Here is the waveform of half wave rectifier output. For the given waveform, we need to find out the function in the limits of from the limits of 0 to pi. The function is I of t equals to Im sin omega t from the limits pi to 2 pi. Its value is I of t is equals to 0. See, you can observe the waveform. Now the waveform is look like a pure sinusoid waveform 0 to pi, whereas from pi to 2 pi its value is 0. Now the formula for average value f average is equal to 1 by t integral 0 to t f of t dt. Now here the function is time period is 1 by 2 pi into 0 to pi Im sin omega t d omega t. From pi to 2 pi its value is 0 into d omega t. Now this integral of 0 will be 0. Now you have a function 1 by 2 pi integral 0 to pi Im sin omega t dt. Now if I take common Im common, it is Im by 2 pi. Integration of sin omega t is minus cos omega t with the limits of 0 to pi. Now here I substitute the upper limit as well as lower limit. Minus Im by 2 pi, cos of upper limit is cos pi minus cos 0. The value of cos pi is minus 1 and the value of cos 0 is 1. Now by substituting the values here, the value of average value is Im by 2 pi into minus 1 which is minus, here is minus n, here also minus n is will be plus n to Im by pi, which is equals to Im by pi which is equals to 0.318 Im. Im by pi is 0.318. Im by pi is 0.318 Im. Now root mean square RMS value, root mean square value can also be find out for a full cycle. The formula for root mean square value is FRMS equals to 1 by under root of 1 by t into 0 to t f of t whole square into dt. Then the value of IRMS is 1 by 2 pi into 0 to pi. First function is from 0 to pi, its value is Im sin omega t, that is Im square sin square omega t into d omega t. Second function is 0 into d omega t. The second function is 0. Then the value of IRMS equals to Im square by, here I am taken Im square common, Im square by 2 pi into 0 to pi sin square omega t d omega t. Therefore sin square omega t can be written as 1 minus cos 2 omega t by 2. Here this 2 also taken common, Im square by 4 pi into 0 to pi 1 into d omega t minus integral 0 to pi cos 2 omega t into d omega t. Therefore, now by substituting the limits, we can find out the value of IRMS equals to under root of Im square by 4 pi into t with the limits of 0 to pi and sin 2 omega t by 2 the limits of 0 to pi. Now by substituting the limits, sin 2 pi value is 0, sin 0 value is also 0. Then here pi and pi will be cancelled, which is the value of IRMS is equals to Im by 2, which is equals to 0.5 Im. This is the value of IRMS. Now we are already finding the average value, which is 0.318 Im, and the RMS value, which is 0.5 Im. Form factor is the ratio of RMS value by average value. Since the value of RMS value is 0.5 Im and the value of average value is 0.318 Im. .572, and similarly the value of peak factor is maximum value is Im and the value of RMS value is Im by 2, therefore which is equals to peak factor equals to 2. Derive the expression for relationship between phase and line voltage and currents of a three-phase balanced star connection as well as delta connection. Consider a three-phase balanced star connection. A balanced star current system is one in which the three-phase voltages are in equal magnitude and are displaced by 120 degrees each other. The load is connected to the system is also balanced by considering a three-phase voltages with a 120 degrees phase shift as shown in figure. The three-phase voltages are having the waveforms VRN, the R phase, Y phase as well as B phase. VRN is the V, which is equals to Vm sin omega t, and Vyn equals to Vm sin omega t minus 120, Vbn equals to Vm sin omega t minus 240 R, or we can write it as Vbn equals to Vm sin omega t plus 120. These are the three phase voltages. Now if you consider a three-phase system with a balanced three-phase load, here if we connect a balanced three-phase load, here Y and Y are connected and B and B are connected. If R and R is also connected and neutral is connected. Here if the load is also balanced, here in all the cases only Z is there. Now here we know the value of VRN, VYN and VBN. Now from that you need to find out the value of VRY, VYB and VBR. Magnitude wise, VRN is equals to VYN equals to VBN equals to V phase, and the values of current IRN equals to IYN equals to IBN equals to I phase. Now the line voltages means it is a phase to phase voltages. VRY equals to VYB equals to VBR equals to VL, and the values of current IR equals to IY equals to IB equals to I line. Now by considering any one of the two branches, VRY is equals to VRN minus VYN. By drawing in the phasor diagram, VRN, first of all we are taking as VRN and VYN and VBN. Now minus VYN is opposite exactly. Now here is the minus VYN exactly opposite to VYN. The resultant of minus VYN and VRN will give us the VRY, which is VRY. Now this is like a parallelogram. Now from parallelogram, you can write under root of VRN square plus VIN square plus the angle is 2 VRN VYN cos of 60. The angle between VRN and VYN is 60 degrees. Now the cos 60 value is 1 by 2. Now by substituting the VRN square, now which is magnitude wise VRN, VYN and VBN are same, you can write it as VRN square plus VYN square plus VBN square, which is equals to V phase square plus V phase square, which you can write as VL equals to root 3 V phase square. Now square and root will be cancelled. It is VL equals to root 3 V phase. Now similarly you can able to find out the VYB and VBR. Now by drawing you can find out this expression. This is the phasor diagram of VRY, VYB. Here is VRY, VYB and VBR. Now coming to the expression for power. Power P is equals to 3 V phase I phase cos pi. Now you can write it as root 3 into V phase root 3 I phase cos phi. Now root 3 V phase we can write it as V line into I line into root 3 into cos pi, which is equals to root 3 VL IL cos pi. Now for star connection, IL is equals to I phase and VL is equals to root 3 V phase. Now this is for the star connection. For a star connection, IL is equals to I phase and VL equals to root 3 V phase. Now this is the expression for power. Power equals to root 3 VL IL cos phi. Similarly, we can find out the values of in delta connection. Now if you consider a delta connection, a balanced delta current system which considers the three phase voltages are having equal magnitude displaced by 120 degrees each other, the load is connected to the system is also balanced, and the three phase voltages are given by VRN, VYN and VBN. Similarly, as the load is balanced, the currents Three currents IRN, IYN, IBN are also having a phase displacement of 120 degrees each.
Please subscribe, share and comment if you like.